Hello everybody, this is Andreas from the Fasttrack ATPL team. You can find our application in the App Store as well as in the Play Store. Name of our application is Fasttrack ATPL. Today I'm going to talk about the topic channel navigation, especially about Polarstereographic charts and some calculations. As you can see, I've already entered our application and I've chosen channel navigation. On the left hand side you can see all the subcategories. I simply select all of them today, and on the right hand side you can see the number of questions. We have total 420 questions in this topic, all of them explained step by step. Then I start the training, and on the left hand side I simply search for the term polar. On the left hand side you can also see all the results which are related to this topic, and I simply start with this question: which one of the following statements is correct concerning the appearance of great circles with the exception of meridians on a Polarstereographic chart whose tangency is at the pole? First of all, you will most probably need this kind of navigation when you're flying long range over the pole, for example from Middle East, let's say, to the United States or North America, Canada. You will get quite close to the North Pole, and then you will plot your track on Polarstereographic charts. Anyway, you can see 4 different answers. One of them is of course only correct, and on the right hand side bottom corner you can see the show solution button. And here we provide you with a simple drawing which should indicate a Polarstereographic chart and also the great circle tracks. So as you might see, the further south you're going, or let's say the closer you are to the equator, the more the great circle tracks are convex to the equator, and the more north you're going, or the closer you are to the pole, they look more like a straight line. And this is basically already the answer to this question. The higher the latitude, the closer they approximate to a straight line. So let's jump to another question. Here we have to calculate something. 2 positions plotted on a Polarstereographic chart, A and B, Alpha and Bravo, and also the coordinates are given. They are joined by a straight line whose highest latitude is reached at 35 degrees west at point B. The true course is, and that's the question. We have 4 different answers again. Let's jump directly to the solution. Again, you can see a drawing, Polarstereographic chart. West, east is indicated, the North Pole, as we are in the north, or northern hemisphere, let's say, point A and point B. And then we have an explanation here, which tells us the shortest distance between 2 points is a great circle, as you might know already. And what I mentioned before is the great circles on the northern hemisphere are bulged downwards towards the equator, let's say convex to the equator. And then if you're going on a westerly track, on a great circle track, the northern hemisphere, the value of the track is constantly decreasing, whereas on easterly tracks the track is constantly increasing, which means you would end up at the North Pole at the end. And if we keep in mind that we are flying from east to west, our direction is or would be 270 degrees, as you can see here, from east to west. Then we have to, or then we want to know the peak of, or say the turning point of this great circle between these 2 points, and this would be at 35 degrees west, as mentioned in the question. What else we want to know is at point B the true track, and the location of point B is 70 degrees north and 102 degrees west, and the peak is 35 degrees west, so the difference is 67 degrees from our peak. Then we have to determine in the next step the mid-latitude, which is calculated by 8 degrees from point A, plus 70 degrees from point B, divided by 2 is 75 degrees. And in the next step we apply the formula now for the convergence of meridians, which is calculated like this. It's delta lambda times the sine of the latitude, and, or let's say in this case, the mid-latitude. Inserting all these values, the sine of 75 times 67 degrees, which is the difference from our peak, gives us a value of 65 degrees. So, and as we are on a westerly track, what I mentioned before, when you are going west, the track is constantly decreasing. We have to subtract 65 degrees from 207 degrees. This is the track at the peak, which gives us the true track at 102 degrees west, equals 205 degrees. I just open the window that you can see this a little bit better. That's the final calculation. And let's see if this is correct. Yes. Yeah, that's it from my side basically. I hope you liked the video and it helps you or helped you to understand these questions. And thumbs up for the video if you liked it, and please leave a comment. Thank you and have a very good day.